So this test is going to be the amplitude flatness test, whereas the previous test that I did was the AC amplitude, where the frequency was held at 1 kHz and the measurement done in RMS across a number of output voltage levels that were within the capabilities of the bench multimeter here. The amplitude flatness test is keeping the output voltage constant but measuring it over a wide range of frequencies, which for this particular unit would be done at 500 kHz, 1 MHz, 5, 15, 25 and then 50 megahertz. And in order to do that, that will take the frequency. This can measure up to 300 kilohertz, so it goes beyond the frequency capability of this instrument. Therefore I have here a little power meter that has actually come from eBay, and we'll give this a go and see what we can measure with it. So again, just one channel, although when you're doing these tests on a calibration you would do both channels. I'm just going to show the one channel, so we'll swipe channel 2 off. The actual output I want in actual dBm this time, and I just want to set that up to 4 dBm. Okay, and because of this meter here, I'm going to go down for the reference level of 1 kilohertz. Okay, so we'll switch on the output, and there's our millivolt level there. Okay, so that's our reference value that we would be looking at. What you can do with the Fluke here, if I get this right, you can change this to dBm anyway. We're at 0.097 dBm. My error. Okay, so what the meter actually has is a dBm reference, which is set to 100 at the moment, as in the termination, but obviously I'm set to a 50 ohm termination, so we need to go to 50 ohms, and then we have the 3.98 dBm now, which would be within the specification for this unit, which is plus or minus 0.15. And the maximum I can take this instrument to, I believe, is 300 kilohertz, but we'll go up a few. 10 kilohertz, it's the same. So at 100 kilohertz it dropped to 3.95. Let's just go up to, which is the max, back up to 3.97 on that one. So after we've done the reference, we move to this. This has a input capability of minus 5 dBm to minus 55. So obviously at 4 dBm I would overload this, and its input frequencies is 1 megahertz to 8 gig, I think. So what I'm just going to do is put on a 20 dB attenuator there. So with a 20 dB attenuator on 4 dBm, you can see that I get well in between minus 5 and minus 55. So adding a 20 dB attenuator will protect this instrument here. And unfortunately, because this is SMA input, I can't use the original lead. I have to change this lead, and I will rezoom this in. We need to go to 1 megahertz before we do that, because that's the minimum that this will read, and I'll zoom into this and then we'll get a better picture. Okay, so it should be able to read this now. So we're set to 1 megahertz. We've got a 4 dBm output ongoing with the 20 dB attenuator, and you'll see I'm reading minus 18.6. And what I can do to change the setup on this, go the other way, come down here to the bottom, and this is the offset. So if I enter the attenuation value, that should then give me 4 dBm reading, but it's not. I'm not 100% sure what's happening with this instrument. I don't know whether I've damaged it or whether it arrived faulty, but whatever I do, I can't get the correct readings. And if I will just change this up to, we'll go to 10 megahertz. So we're at 10 megahertz on the app generator. I now need to change this to 10 megahertz as well. I'll get that one, down one. And now I'm getting 4.1 dBm at 10 meg. So we'll go 25 megahertz on the output. 25 megahertz, we get 4.3. And we can go finally up to 50 megahertz. 50 megahertz, I get 4.2, which is also correct. So let's just pop him back down, go down to 5 megahertz. Keep putting my hand in front of the display. It's me changing the settings on the Tektronix. I apologise for that. Just didn't set this up properly, really. And he's 3.9, which would be in spec. So let's just see where he drops off. 4 megahertz. So it could just be the accuracy on this instrument. Yeah, 4 megahertz is 3.4. Take it down to 2 megahertz. 2 megahertz is 2.7. Okay, so it could well be. It's just, although this can read down to 1 megahertz, it might be that it's getting inaccurate at 1 megahertz. And its accuracy seems to come on at around about 5 megahertz. So I guess that's what you get for slightly cheap RF power meter. I have ordered another one, a different one to this one. It's a higher specification, so when that arrives I'll put that together and I'll test that against this one using the Tektronix, and we'll see what it comes out with. Yeah, so unfortunately that's it with this part of the test until I sort out another RF power meter. But thanks for watching anyway, and again I'll see you in the next video.